Like we start now coming to the controllers of the control systems. Like you must be have idea about this proportional derivative and integral controllers. So not only one thing, you can also combine both of them or three of them for getting desirable property or desirable conditions from a controller, like for getting desired output at the end. So here we are going to look at the different like advantages or important points regarding each type of controller, like where we can use or where we can go for particular controller, like that. So coming to the proportional derivative controllers, so using these controllers you can improve bandwidth, gain margin, phase margin, and resonant peak and damping. Okay, and these controllers will reduce rise time, settling time, and peak magnitude. Okay, it means it increasing the speed of the response. Okay, decreasing the rise time in the sense it is increasing the speed of the response, right? The speed and time are obviously inversely proportional. Okay, so speed is increasing means the transient response is improved, because the rise time is the time before steady state, that means during the transient only. Okay, and coming to the third point, the steady state error is going to decrease if it varies with time. Okay, using proportional and derivative controllers. Coming to the proportional integral controllers, the rise time is going to increase, and so the bandwidth is going to reduce, like it is opposite to the PD controllers. Like, because derivative and integral are inverse to each other, right? Because derivative is having s Laplace transform and integral is having 1 by s, so the properties will be inverse to each other mostly. So as in the PD controller the rise time is decreasing, here in PI controller rise time is going to increase, and so bandwidth is going to reduce similarly, but the steady state error is going to reduce. Okay, even with the proportional integral controller, and type increases by 1, because what is meant by type of a system, it is the number of poles at s equals to 0. So if we add an integral, you are getting 1 by s part. Okay, so the type is going to increase by 1. Then coming to the most practically used controller, that is PID controller, it is going to add the advantages of both PD and PI controllers. That's why this is preferred in practical. Then there is one definition, you might get any question from this, mostly you may not get, but let's see. So that is proportional band. So it means, suppose 10% proportional band means 10% change in controller input is causing a full scale change in controller output. Are you getting? So whatever be the proportional band, for that much percentage change in the controller input, you are going to get a full scale change in controller output. Okay, so here the controller gain will be Kc is equals to 100 divided by proportional band. This is one formula. Okay, they may give you proportional band and they may ask you to find out controller gain. In that case you need to use this one. Okay, so finally if you consider the each type of controller, that is proportional, integral, and derivative, each are having these advantages. That means proportional is going to improve transient response. Okay, that means it is going to increase the speed. Similarly, integral is going to improve the steady state response, and stability is going to reduce. Okay, and derivative is going to improve stability and transient response, but the steady state error is going to increase. Okay, right, you look into these things, you will get to know, right?